We have 3 items here in the list, which we'll come to, and they all support what we call the open standard-based digital twin. So for us, it's important to focus that we are open standard-based, and many are doing digital twins, and that's what we do. We focus on data management. That's a bit away from what Elizabeth was focusing on, so that's a good, very complementary. Yeah, and our toolkit is called Express Data Manager. A few words about us. JOTNE, we are a small and medium-sized company in Oslo, in Norway, privately owned. One part of the group deals with IT. So we see here JOTNE IT, and we are also called JOTNE EPM Technology. We are really the partner here in the project, JOTNE EPM Technology. And we address these business verticals that I mentioned here: built environment, and then aeronautics, defense and space, ASD. And for all, it's this common denominator is this Express Data Manager. This is a database management system specifically designed to support ISO 10303 step. So there is a data modeling language called Express, and such Express models, which are the standards themselves, can be directly compiled into the database, and that's what we consider a very good, very big advantage, and to also reflect reality without any gap in mapping it to other types of database systems. Yes, well, the benefits of what we deliver. As I said, the keyword is data management, and here it says project data management or product data management. The systems are flexible. So we bring, these are collaboration tools. They're not replacing any authoring applications, engineering applications, but they're more the glue between CAD, CAE, CAT, CAM, and what you know, how name it. So from those applications, we take data and import the data into our environment for there to be browsed, validated, and interlinked also. So we are quite good with these applications in history tracking. We do data packaging. It's of course a source for feature extraction. So when you do want to use AI or ML methods, so artificial intelligence or machine learning, as an example, we can provide the database for that. We don't have these methods ourselves, but we have then standard access methods to get access to the data. And of course, exchange of data with others and archiving are advantages. Coming back to that. The pictures, they simply show use cases that we have been doing. The recent developments are really then integration with the IoT world, so that we can also read and stream data and store stream data. So there, the cooperation, you can say, with edge type devices and so are in scope, but this is what is is in our developments currently. Capabilities, yeah, managing product lifecycle data. I said bring it all together. So from idea to yeah, recycling. So circular manufacturing is quite in. So that's also part of both these standard data models in STEP and our tools. Document management is part of it, of course. Longevity, as I said, archiving is one of the advantages of the applications, because the data are stored according to the standard. So when you in 50 or 100 years want to do something with the data, you still can find the specifications. It's openly available. You know how the data are organized and how they are stored on a file, and can then develop software in a way to, for example, to reuse them. Yeah, as I said, the latest developments are then concerning IoT. It's all standards-based. Predictive maintenance is an example of an application which is typical. Yeah, and real-time data are streamed for us. We saw that now in my previous presentation a bit about STEP and ISO 10303. Many of you will probably know STEP from their CAD systems, so those who work with CAD systems, because almost all CAD systems have an export to STEP, and that's where the knowledge usually ends. So STEP is not only CAD. STEP came into being because it could represent 3D models. And that was, as it says here, 94, that data model and that data sharing capability was launched and has since been implemented. But then other domains were added, PLM, how to represent assemblies, design, bill of materials, change nodes, and so on. Also before 2000, we have then ILS, which is integrated logistics support. So the main part of the life really of a product, right? When it is taken into operation and is maintained, you need to know where the spare parts are and which skills you need to change it, all that. That type of information is also represented in the STEP data models. And here we are into computer-aided engineering. So analysis data, finite element, computational fluid dynamics. Now we found out also testing data, physical testing can also be represented in STEP. So as you see, it's a wide model, and it's not, of course, not totally complete. There will always be some domains which are not included yet, and this is what we could contribute with to the standard, saying that, well, in my domain, this is missing, edit. And we have done that earlier together with SINTEF and an EU proposal, EU project that we enhanced the STEP standard very concretely. Then what are the tools really? So as I said, there are three. There's one tool which is called EDM SDK, which is a software development kit, which is a toolkit to implement a data converter, specifically express-based data. That means here for STEP data. So either to read STEP data or to write STEP data to or from a proprietary format, for example. This is, of course, necessary in many cases because many applications, either they are just locally in a company or they are simply haven't any STEP export import, would need to be enhanced with such a converter. And that can be done even though the vendors do not themselves provide STEP access. Then we have one tool which is called EDM through PLM. So PLM is the probably most known keyword there, product lifecycle management. Here data and documents are collected, probably based on imported PLM or CAD data, so that you have a structure, product structure in there, and then you can add data that either manually or from sensors to make this a living digital twin, which then can provide data to further processing downstream. And we have a tool which especially deals with analysis and testing data. So here we really make what we call a federated model, where we integrate the various data sets that are imported into a single data set, which is interlinked, so that you really can do a very close correlation of data. This is called EDM Open SynDM. Getting more to the end. If you want to learn more about how it was used in the pilot, in the pilots, you can look into space structures. They can read in D33. Don't need to go into more detail there. I had a little example use, but due to the lack of time, don't go into detail there. You only see that the various formats here, the various formats are converted into the same and are then made, a consistent model, which you can do validations, comparisons, and correlations. Thank you so much.
Thank you, Jochen.